Hello and welcome to this video on calculating masses in reactions. So I've got a question up here in blue, which is what we're going to be doing the calculation for. So it says we burn 10 grams of magnesium to make magnesium oxide. How much magnesium oxide is made? First step in doing one of these is to make sure you have the balanced equation. So we're going to have magnesium, we're going to react it with oxygen to make magnesium oxide. Now this doesn't balance at the moment because we've got one magnesium on the left, one on the right. That's okay. I'll do a little dotty line here, this is what I always like to do. But I've got two oxygens on the left and only one on the right. So that's not going to work, that doesn't balance. Now remember, I'm not allowed to just put a little 2 in here, that's not allowed because that changes the substance. That would be magnesium dioxide, which can't exist. What I can do is order, or just put a big 2 in the front here. I always teach my students about like ordering boxes of things. I can order 2 lots of that entire chemical. So I've got 2 lots of magnesium oxide. Well, now I've got 2 lots of oxygen, that matches up, but now I've got 2 magnesiums over here and only 1 over here. So I can just order 2 lots of magnesium there. So there we go, there's our balanced equation, we're ready to start. Now we need to go back and apply what we learned about relative formula mass. So magnesium has a mass of 24. So that comes from the magnesium, but there's 2 lots of it. So it's going to be 2 times 24, which will be 48, if my maths serves me right. It doesn't actually ask us in the question, going back to a bit of exam technique, we burn 10 grams of magnesium to make magnesium oxide. How much magnesium oxide is made? It doesn't ask us any questions at all about the oxygen, so we can cross that out and we don't have to worry about it. So now we're going to be going over here to our magnesium oxide. So we've got our magnesium, which has a mass of 24. We've got our oxygen, which has a mass of 16, so we're going to add those together, but there's 2 lots of all of that. So we're going to times it by 2. So now I've got my calculator off screen. I don't do maths in my head because I always get it wrong and my calculator's betraying me. 24 plus 16 equals times 2. 80. That should have been easy enough for me to do in my head, really. I'm tired. So what we now know, just using relative formula mass, is that 48 grams of magnesium will turn into 80 grams of magnesium oxide. Now from our question, we don't have 48 grams of magnesium, we've only got 10. So what we're going to do is take the side of the equation that we know the most about from our question, which is this side, because it tells us we've got 10 grams of magnesium, and we're going to try and turn this number into 1, so it's 1 gram. Now the easiest way to do this is by dividing it by itself. So I'm going to divide that by 48, which will equal 1 gram. Now, in maths, if you do it to one side of an equation, you've got to do it to the other, and it's just the same here. So if I'm going to divide that by 48, I've got to do the same over here as well. So now I'm going to do 80 divided by 48, which is 1.6 recurring, so I'm just going to call it 1.7 grams. So now we know that 1 gram of magnesium will burn in oxygen to make 1.7 grams of magnesium oxide. Again, back to our question, we don't have 1 gram, we've got 10. But now it's nice and easy, because to turn 1 into 10, we just times it by 10. And if we do the same over here, if we do something to this side, you've got to do it to the other. So we're going to times that by 10 as well. And that will give us 17. So 10 grams will make 17 grams of magnesium oxide. That's it.